Hello, students. So this is the second in the trig functions and right triangles lecture. And in this, I'm going to do some computer-aided computations. I can use a computer to compute trig functions. And I'm going to use that fact in order to determine facts about triangles. So let's go ahead and get started. So here's one. Suppose a surveyor sets up an Abney level 100 meters from a building and determines that the building's roof is 25 degrees above horizontal. So before you even continue, you should go ahead and take a moment and look up what an Abney level is. So what it is it's one of those little doodads that you see surveyors using when they want to determine the height of a building. It's like a little tripod. That's a tripod. And it has a little like looky-through-y thing like a telescope, but it doesn't necessarily need to magnify. It needs to know what this angle is. So what you'll do if you have an Abney level and you want to know the height of a building is you'll point it at the top of the building. Then this angle is the angle, it will give you an angle of elevation that you're looking at the building at. And if you know how far away from the building you're standing, that's enough information to determine the height of a building. And let's do exactly that. So a surveyor sets up an Abney level, one of these doodads, points it at the top of a building, measures an angle of 25 degrees above horizontal. Using one of the little wheelie-doos that surveyors use to measure distance. So just a little thing that has a wheel on the bottom that will count how many times that wheel spins around as you walk from point A to point B. If you know the diameter of that wheel, then you can use that to figure out the distance that you cover. So a surveyor walks using that device to measure 100 meters from the base of a building. Here's that building. Sets up an Abney level here and measures an angle of 25 degrees. Let's try to determine how tall that building is. That picture is now messy, so I'm going to redraw the picture. So here's the picture. It's a right triangle. The base is 100 meters. This angle is 25 degrees. I would like to know what that side length is. And I'll do it in terms of SOHCAHTOA, because the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So let's see what we could use here. So let's just think about it one at a time. So if we were to use sine, that would be something that would reflect an interaction between opposite and hypotenuse. I don't know either of those. So I'll have an equation with two unknowns. You can't solve that. So cosine is adjacent over hypotenuse. That doesn't involve the quantity that we would like to know, so that's not useful. Tangent is opposite over adjacent. Oh, neat. So tangent of 25 degrees is question mark over 100 meters. So using that, tangent of 25 degrees is equal to opposite over adjacent. Oh, so that's something that I can totally solve for question mark. I'll get question mark is equal to 25. Nope. Tangent of 25 degrees times 100 meters. And that's not something that I can compute by hand. I don't know what the tangent of 25 degrees is without doing some approximations. Let's have a computer do those approximations. I'll do that really quickly and I'll come back to you. All right, here we are. So I've just asked Google, in this case, to compute 100 times the tangent of 25 degrees, which is exactly what I wanted. So let's just write that down. 100 times tangent of 25 degrees is 46.6. And now let's put the units back. So that's approximately 46.6 meters tall. And let's just remind ourselves right here we have an exact answer. This is an approximate answer. So, you did this computation on your own. It's possible that you got a very different looking number from what I did. So if you did, what it might be indicative of is that your calculator is not in degree mode, it's in radian mode. So 100 times the tangent of 25 radians is negative 13.3. So that's obviously an unreasonable answer. So the takeaway here is if you're going to use a machine to do a computation, make sure you know whether you're in radian mode or degree mode. And the best advice I can give you, well, you can send me an email, but you'll be able to answer that question just as well by pulling out your calculator's manual. See how to switch from one mode to the other. And you can send me an email if you have any follow-up questions about that. So let's carry on. So here's another similar question. Let's move this out of the way. I will need it later. The cats are fighting. That's what you hear. So here's a question, a very important one. So let's suppose that you know that a building is 100 meters tall. Maybe you went and used an Abney level to figure that out. Now on top of that building, someone has installed a statue of a horse. So right here, that's... I can't actually draw the picture, but imagine there's a statue of a horse atop a 100-meter tall building. You want to know how tall that horse is, how big the actual statue of the horse is. Now, you can't measure it on your own. You aren't going to like climb the building to measure the height of the horse, or to do so would be reckless and silly because there's an easier way to do it. If you happen to have something like an Abney level, which really all you need to generate an Abney level is a meter stick, a compass, just a thing to measure an angle, and like a toilet paper tube to roll through, to look through, because all you need to do is set up this toilet paper tube. You'll hold that up at an angle. From that, you'll let the meter stick drop so it's vertical. You'll hold the angle right here, and you'll be able to measure this difference between vertical and how the meter stick is lying, is falling. That'll tell you the angle of elevation. But that's not the point. So suppose you've done that. And in fact, a modern Abney level will do all this computation for you, but it's important to know how it walks. So a statue of a horse has been put atop a building. You know the building to be 100 meters tall. You stand back some distance. You don't bother measuring the distance. And you look to the top of the building. You find that this angle is 45 degrees. And then when you look up to the top of the horse, it's up at 50 degrees. So that's an additional 5 degrees. So this is a 5-degree angle. This red angle is a 45-degree angle. Here's what I want you to do. Pause the video. Figure out the height of that statue of a horse. Figure out how big question mark is. Okay, good. You did it. Now, I'll do it. So here's how I'll think about it. So one thing I see is this is a... Oops. That's not what I wanted. This is a 45... Well, let's just do it. You could notice that's a 45, 45, 90 triangle. So the base has to be 100 meters. But if you don't notice that, you can also just figure out what the base is by doing some trigonometry. So let's try to figure out this length. So I certainly have the opposite. I would like to know the adjacent. So TOA is the thing to use there. So tangent of 45 degrees is equal to opposite 100 meters over, let's go ahead and call this x. It's a horizontal thing even. Now you might use a machine to make this computation, and that would be fine right now. We haven't computed anything rigorously, but tangent of 45 degrees works out to be 1. So that means 1 is equal to 100 meters over x. That means x is equal to 100 meters. All right, so now let's look at the whole big triangle. So let's look at this whole big triangle, where this is a 50-degree angle. This length is 100 plus question mark. This length is 100. Oh, it looks like TOA is relevant again. Tangent of 50 degrees. 50 degrees isn't an angle that I know the tangent of, so I'll have to use a machine to help me when I want to actually do the final computation. Tangent of 50 degrees is opposite over adjacent. There's the opposite. There's the adjacent. Let's write it out. Opposite is 100 plus the unknown side, the height of the horse, the thing that I would like to know, divided by adjacent is 100. Solve that for question mark. So I guess one way to do it is multiply the 100 to the other side. 100 times tangent 50 degrees is equal to 100 plus question mark. So 100 times the tangent of 50 degrees minus 100 is equal to question mark. So there's the exact value of the height of the horse. There's the exact answer. Now let's get the approximate answer. And here we go. So 100, happily the 100 is still 100. 100 times 50 degrees minus 100. 19.2 approximately. So question mark is approximately 19.2. And what are the units that I'm walking in? Meters? Meters. Awesome. And again, let's just remind you, there are two answers given. This is the exact answer. This is the approximate answer. And they're both good for different things, right? The exact answer tells you the exact value of the thing and even tells you how you computed it to some extent. And it's useful if then you want to generalize this. If you did this in more generality, you might get a formula. The approximation is nice in that, yeah, I know that it's 19.2 meters now. I know that, oh, it looks like it's even like a fifth of the height of the building. Cool. So, I'll stop this recording in a moment and get it posted, and I'll tell you what we're going to do next. What we're going to do next is we're going to actually compute trig functions at some special inputs. So I'll go ahead and hit stop. Enjoy this. I hope you enjoyed this video.